here is example number 4, and that says y double dash plus y equals to x cos x minus cos x. There are two different types of cos functions. So because of multiplication of x. Okay, for a complementary solution, annihilator part is d square plus 1 into y, and for that I think I have to select n, and I have to select here beta, because I cannot see here any alpha because there is no exponential e to the power alpha x term. So here n, x to the power 1 means n should be 2 and beta should be 1. So that means by this formula d square, no alpha, plus 1 to the power 2. So that is the annihilator operator of this term, and cos x means no n is 1 and beta is 1, so that means d square plus 1. Okay, so combining these all annihilator operators, that makes it d square plus 1, d square plus 1 square, and d square plus 1. Very interesting example this is, because I can see the repeated roots, I can see simple and repeated but complex roots, not simple. Okay, so that makes it 1, 2, 3, 4. D square plus 1 m square equals to minus 1. So first of all you have to find out the iotas from that. Plus minus under root minus 1, that is equal to plus minus iota. There is no alpha, only beta, but 4 times. So that means it should be in the complex plus repeated roots. So y is equal to c1. There is no exponential function. So cos x plus c2 sin x for first one. You have to write it 4 times. Plus c3x cos x plus c4x sin x. Wow. Plus c5x square due to the third term repetition, x square cos x plus c6 x square sin x. And last one is plus, because we have to write it 4 times. So c7x cube cos x plus c8 x cube sin x. That's so interesting one and so easy one. And one more thing is that if you write its common annihilator operator, because this annihilator operator annihilates these 2 values. So if you skip this d square plus 1, then you can only write is d square and no need of writing d square plus 1. So you will finish with this c6. You will not need to write this c7 and c8 terms. So that will be. So next example is y double dash. Example number 5 is y double dash minus 2y dash plus y equals to 10 e to the power minus 2x cos x. So annihilator operator for the left hand side is d square minus 2 into d plus 1, and for this rest of the part it falls into the category of 3. So alpha here, I can see that alpha here is minus 2, and beta here is 1, and x to the power 0, so n is equal to 1. So that makes the annihilator operator 2 minus 2 into minus 2 square plus 1 square to the power n, d square plus 4d, that makes it minus 2 square, makes it 4 plus 1, that makes it 5 square, 1, not square, it is 1. So you can find out the roots. Now you multiply these 2 values 2d, and you can factorize it with the help of auxiliary equation. So is equal to 0. So again, auxiliary equation is 2m plus 1 m square plus 4m plus 5. So what are the roots? Minus 2m makes it, you can use the quadratic formula here. M equals to minus 4 plus minus 16 minus 20 divided by 2 minus 4 plus minus 4 by 2 minus 4 plus minus 2 iota by 2, and that becomes minus 2 plus minus iota. So here alpha is minus 2 and beta is 1. So again, so y is equal to c1 e to the power x plus c2x e to the power x plus c3 e to the power minus 2x cos x plus c4 e to the power. So that is the particular part and that is the complementary part. Okay, fine. Next example is y third derivative minus 4 y double dash plus 4 y dash is equal to 5x square minus 6x plus 4x square e to the power 2x plus 3 into e to the power 5x. So basically there are 3 g of x. So first of all, this differential annihilator operator is d cube minus 4d square plus 4d. And for that first part, 5x minus 6 square, 5x square minus 6x is d cube. And for this part we can see that now we can write it directly. So n is 3 and alpha is 2. And also here for this part, d minus 5 to the power 1. Okay, so multiply all these annihilator operators, d minus 2 and 3, d minus 5 and 0. So make its auxiliary equation. I can also take 1d common and that becomes d4. That makes it d4, and d minus 5, d minus 2 cube, d square minus 4d plus 4. Again, that is a square minus 2ab plus b square. I guess that is formula. So d minus 2 square. Oh my god. It blends it into this homogeneous and particular part. No need to differentiate now. So that construct the solution out of that 4 times repeated roots 0, c1 plus c2 x plus c3 x square plus c4 x cubes for this. And for the next one is c5 e to the power 5x and 5 times e to the power 2x plus c7x e to the power 2x plus c8 x square e to the power 2x plus c9 x cube e to the power 2x plus c10 x4 e to the power 2x. 1 2 3 4 5. So solution for this. So that is the answer, and it is, you know, it is very interesting, and I really like this method because with solving comparing coefficients, particular solutions. So if you have any questions, you can ask me in the online lecture, and I hope that you all understand this interesting method. Thank you so much.